here, and this is kind of the packet now. So this would be available to you in the class drive of geometry, but you don't need to have it as far as printed out unless you want it. Okay, so it would just be the packet that I would give you. It's there for you to look at. You should be able to. I had it set up so that you should be able to look at it. All right. I'm going to have it on OneNote, so when we go through this video, it's going to be there. You'll be able to see it anyway on the video. But if you just feel like, hey, I got to have that in front of me, you'll have to print it out. It's a pretty big packet, but you know, that's what it is, so you can decide what you want to do. Anyway, so normally we'd be having somebody read through this. None of this information was already on the video, so I'm just going to kind of go through and mention a couple things here. So we got King Tut and Khufu, kings of ancient Egypt, and they, of course, were popular. They're kings, and so they built pyramids at Giza with the 7 wonders of the ancient world. That was all on the video. Still standing after 4,500 years, the Great Pyramid is an amazing architectural monument. Designed in Khufu's burial tomb, the structure is a regular square pyramid, which originally stood 147 meters high. Each side of its square base measured 230 meters, as shown in this figure. So these numbers, the 230, the 147, you can see the triangle kind of on the inside of it. That's going to be important to us. We'll come back to that. So the Great Pyramid consists of about 2.3 million stones. We got all that out of the video, which talked about how much it weighed and how long it took them to do it. The base of the Great Pyramid is nearly a perfect square. To build a structure of this size to such exact specification, Egyptian engineers and surveyors must apply some mathematics. Due to the lack of written records, as I said in the video, however, historians are unsure about exactly what they used to do it. All right, so I'm going to zip down here to activity number 1, where it says modern engineers use precise measuring tools to stake out the corners of a building's foundation. However, the Egyptians located the corners of the Great Pyramid without the benefit of such tools. In this activity, we're going to take a look at it. So in this exploration that we're going to do, we have when 2 or more people make the same measurements, they may obtain different values. In some cases, a small difference in one measurement can have big consequences for another. In this exploration, we're going to use proportions to investigate this possibility. All right, so before we jump into this, all right, it talked about using proportions. Okay, so I'm hoping that I can. Okay, so we're back. So what we want to do, though, before we do this little exploration here, and it mentioned proportions. Okay, so we didn't get a chance to work much with proportions on the module that we had before the closure. All right, so that's what we're going to do now. So let's talk about, first of all, what a ratio is. Okay, so a ratio is a comparison between 2 sorry about the tapping quantities. All right, so you often write a ratio as a fraction, right? Like 3/4. You can write it as a colon, 3/4 that way. You can write it as 3/4, okay? But those how you write a ratio, okay? 2 quantities. So a lot of times a ratio will be like a rate, so like miles per hour. So if you were going 60 miles per hour, that would be a ratio because you got 60 miles in an hour, miles per hour, all right? You could have a ratio in terms of maybe a recipe, okay? So if you've got, say you have Flour has been a very popular thing here. So if we have 3 cups of flour, all right, per 2, maybe you're making some bread or something, right? You need 3 cups of flour per 2 loaves of bread, something like that. Maybe not very big loaves. All right, so that would be a ratio, cups to bread. All right, a lot of times, man, years ago when they had like snowmobiles were like this, some lawnmowers, that kind of thing. They used a blend of oil to gas. It's called a power mix. All right, so you might have like 2, say, ounces of oil, okay, to 1, gallon of gas or something like that. All right, and that probably wasn't quite it because I can't remember exactly what the ratio was. So that would be a comparison between the 2 quantities. A proportion is 2 equal ratios. All right, so for a proportion, all right, come on. Man, we're having troubles here today. There we go. So a proportion with 2 equal ratios, so we could have something like 3/8 equals x over 10. Right? That would be a proportion where we don't know what x is. Right? And the most famous way to do things like this is cross multiply. And cross multiply, all right, is one of the most important things you can learn in mathematics for real life applications. I mean, cross multiply all the time. And some of you, when I was reading your little reflections on the things you did when you closed, you were making, you made a lot of stuff. You were making dinners and breads and cakes and cookies and all kinds of things. I thought, man, I should be at their house. They got great stuff going on there. You may have used proportions to figure recipes. I probably didn't know it, but you did. All right. So, for example, maybe we had something like this one, okay, and then you would have to cross multiply. So cross multiply looks like this. So we'd have 30, all right, equals 8 times x, all right. And you've done cross multiply before. I know you learned it somewhere, all right. So it's nothing that's new. It's just that we're going to use it a lot, okay. And the next 3 units, hopefully we get to 3. We're not exactly sure where we're going to be. We're going to use cross multiplication a lot, all right? So usually, if this was a normal situation, I'd say we're going to use cross multiply 1,392 times, all right? But I don't know if we're going to get that many this year, so it's hard to tell. Let's see, I need 30 divided by 8. I think I got a calculator over here on my computer here. Let me check it out. Calculator. 30 divided by 8 equals 3.75. Okay. There we go. Right. And so I'm just going to do some more of these and put the x's in different situations there. Oh, that's too easy. That one's too easy. There we go. All right. So we're still going to cross multiply. 15 times 11. 165 equals 4 x's. Then we're going to divide by 4. Always cross multiply and divide. X equals 41.25. All right. So we'll do another one here. I want to give you different kind of variations of these. Here we might have one where you have even some decimals, and it's okay to have decimals. Maybe it's going to look something like that. Cross multiply. I can do this one in my head. All right. So, and the last one we'll do with cross multiply may not have many of these. I don't know why I just did that, but here we go. So we're going to go a 3 and an x equals an 8 over an x plus 2. All right. So, got some junk there. Here, we're still going to cross multiply, but when we do that, we got to take 3 times the x and 3 times the 2 and the 8 times the x, so we get this. All right. So now you got to go back to your algebra skills that you learned. All right. So we're going to move the x's to one side, move this x over here, move this x over here, and we have 6 equals 5 x's, and we're going to divide by 5. So we get 6 over 5. Oh, yeah, I know that one. 1.2. All right, but you're still going to cross multiply. You just got to make sure you take 3 times both of those things. Move the x to one side, leave the number on the other, and then divide it. Okay? All right, so that is what one of the things we need to know how to do. So I placed an assignment in your Google Classroom for you that's just about solving proportions. Okay? There's some stuff on the bottom. We're not going to do that. So don't get to the triangle stuff. Just work on those proportions. Okay? We'll do the triangle stuff a little later because we have some other stuff we got to do. All right? I'm going to jump back to this pyramid packet thing here and open this up. Hopefully. Let's see. What the heck? Okay, so here we go. We talked about this. So what I did on the board, and I'm going to show you this, instead of using a large piece of paper, I marked a point C on the whiteboard, and then I marked a point D. That was about 30 centimeters away. Okay, then it says draw a line segment from C to D, which I did. Use a protractor and a meter stick to draw a line segment that passes through point C perpendicular to CD. And so I showed that. So what I'm going to do is take and show you that. It's just going to be a quick transition here from this thing to that video. All right, so today we're going to do this little exploration that is in our first unit in this distance learning thing called the pyramids. You watched the video. I gave you a little document on the first part of this so you kind of know what we're doing. Normally, I would bounce around to each group. They would come up and do the little exploration for us, but obviously I can't do that. So what I did though is invited some guests to come along, see if you can figure out who they are. All right, so first thing that I'm going to do, it says, is to draw a segment down here about 30 centimeters long. So let me get a pen here and we'll do that. 30 centimeters long right here. I'm going to move it out over this way. Okay, the protractor out of the way for now. 30 centimeters. There it is. So there's 30 centimeters. And it says to label this point C, okay, and this point D. All right. So then what we're going to do is have the guests come up here and do this, all right, with the protractor and a meter stick. Okay, so here's the first guest. second cast. Third cast. Next. Next cast. Last one. Okay, so now, just so you can kind of see it here, I'm going to pull a little closer, and maybe you can see it better. All right, so you can see the lines, and all made from this point at 90-degree angles. And you might say, well, they're all using the same protractor and everything, right? But human error gives us this off, gives us a little bit of a distance that's off. So if we look at this this triangle, right, I'm going to measure the distance in centimeters across there, and it is 15. All right, so that's not bad, because really the record is like 30 or 40 centimeters or something. I mean, I had some classes that were just, they were way out there. So this isn't too bad. 15, I think we've had it closest is about 10. All right, so you're going to need this information. All right, 15 centimeters is the distance away between these two edges that forms this triangle. All right, so I'm going to go ahead and stop this, and then make it with another video going to come together and show us what we're going to do with this number.